Good afternoon, T-Square Tutoring members. Today, this video is going to be focusing on trig identities, which now that we're looking back on it, I'm pretty sure I misspelled in the title of my Notability doc, but I'm a STEM teacher, not an English teacher. So, here we go. Let's get into it. Now, when I record these videos, I do it in like the relevant context. Now, when I received this from my friend, who I'm going to keep anonymous because he didn't say I had permission to say his name, I basically got them under the context of you would have an equation sheet with a bunch of trig identities on it. So I'm going to try and write them fitting into that context. And, hopefully explain it well enough to even if you didn't have the context of being taught the lesson, having the equation sheet with you. You could still understand it. But with that being said, let's get into it. So we're starting for our first problem. We have cosine cubed times sine squared equals cosine parentheses sine squared minus sine to the 4. Okay, that's a lot of words. So first thing I do when I see this problem was I wanted to break it apart into I wanted to take one cosine out. Just make it squared because those are usually more easy to work with. So I'm going to say cosine theta times, we're going to put times symbol so we know it's separate from the other ones. Cosine squared, sine squared. And I'll write this down when I need to. Just for now, I'm just going to leave it because I am lazy, as you should be. Now, in order to make this cosine squared times sine squared a little bit easier, I think it would be nice if we wrote it all just had it in terms of one of them instead of all these trig functions. Just what if it was all sine? Now, how can we do that? That's a Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So I'm going to write that to the side. I move that to the side for you. And if you notice, if you try and solve for cosine squared by itself, you could just subtract the signs. You'll get cosine squared equals 1 minus sine squared. Sorry for not saying the variable names. I just skip it. I don't know, just my brain's been wired that way now. So my apologies for any confusion that might cause. Anyway, if we have this 1 minus sine squared, let's try and plug it back into our original equation right here. So, cosine theta times, and I'll write this sign on the outside like this, sine squared, 1 minus squared. From here, we can just distribute the sign. So, cosine theta times sine squared times 1, sine squared minus, sine to the 4th theta. You realize, since we took this cosine out, instead of writing a little dot for multiplication, we could use a parentheses. And what do you know? That's what we had originally. So this one was not too hard to deal with. Just for a nice sake. Now we actually set them equal to each other, and we're done for 42. I gave myself a lot more room than I needed to, but oh well. Some problems will take advantage of it, some won't. Next problem. Tangent squared minus sine squared equals tangent squared times sine squared. I do all the videos like beforehand, so I don't make as many mistakes while I'm actually doing it. And I can tell you, this one was a pretty hard one, but, well, I'll say tedious, as in, because it was more of just a lot of work to do than necessarily it was difficult. Anyway, let me stop yapping and just give you what you want. So, one way we write tangent squared, or tangent in general, is just sine over cosine. And when it's squared, you just do the same thing. So I have sine squared of t over cosine squared t minus sine squared t over 1. And I'm writing over 1 for a particular reason. So, and that reason is, it's easier to show that we want to get the same denominator because if we had the same denominator, we could just subtract these, and it makes our life slightly easier. And I like my life being easy. So, in order to get them in the same denominator, you have to multiply. Oh, bless you. And I probably should edit that out, but I don't think I have time tonight. Anyway, so you want to multiply by the respective denominators. So, for this cosine, I want to multiply it by 1 because 1 is the other denominator. But I'm not going to write 1 over 1 because I think we all know what that is. Here, we write cosine squared t over cosine squared t. And that gives us sine squared t minus sine squared t cosine squared t all over cosine squared t. Now, in the numerator, you can see we have two of the same things. This sine t, this sine t. So we can factor those out. You'll get sine squared t, 1 minus cosine squared t. And this is really good for us because it simplifies. Specifically, this is just another sine squared over t. Oh, I almost forgot the denominator. Silly me. So now we have sine to the 4th t over cosine squared t. Which is really close to our original answer. We just need to do one more thing. We want to pull out 2 of these. We have 4 sines. We want to pull out 2. So I have, let me redraw my arrow. I'm going to pull out 2 of them. This is probably the worst notation you've seen, but hopefully it gets my idea across. So we'll have sine t squared, sine squared t over cosine squared t times sine squared t. Now, if you remember from when we started the problem, tangent squared is equal to that. So now we have tangent squared t times sine squared t. And that happens to be the answer. And we are done. Woohoo! My apologies for the lack of enthusiasm. I did not sleep last night. Well, done with 43. Moving on to 44. Oh boy, that was tough. Sine over cosecant plus cosine over secant equals sine times cosecant. Where do we even start with this? Well, we start exactly where we started before, where we multiplied by the denominator of each. Now before, it was nice and fun because you didn't have to do too much. However, now, oh whoops. Sorry, I don't know what I did. But now, it's a little more complicated because we have more complicated denominators. So, from here, we need to multiply by the secant. And since I didn't give myself enough space originally, I'm just gonna slide this all over. You don't mind? Boop. So we have secant t over secant t. And then on this side, we slide this over as well. We need to multiply it by this cosecant here. Oh. Well, sorry for the misclick, but in case you're wondering what just flashed on your screen, that would be Heimler, who teaches AP World and other history-based AP classes. So, my apologies for that. But let's continue with the lesson. So yeah, now that we have in like bases, like denominators. Goodness. I can write this as sine t times secant t plus cosine t cosecant t all over that big base of secant t cosecant t. Or cosecant t, secant t. Don't think it particularly matters. Now these particular functions, when you have a special property. When you multiply sine by secant, you get tangent. And why is that? Simply because secant equals secant of t in this case equals 1 over cosine t. So sine times 1 over cosine t will get you sine over cosine, and that gives you just tangent. The same applies of these two, where you'll get cotangent instead, because cosine's on top, and this is sine on the bottom. So, rewriting that, we'll get tangent t plus cotangent t. Actually, I'm going to rewrite this. Oops, pardon me. I'm going to write this as two fractions because they're both being added. We're going to keep the denominator the same. I'm going to write it as tangent t, secant t, and cosecant plus cotangent t over secant t, cosecant t. Cool. Like I said, tangent is sine over cosine, and cotangent is cosine over sine. More importantly, let's look at our denominators, which is just 1 over cosine for secant times 1 over sine. So we'll get 1 over cosine times sine for both because they're the same denominator. And when you have to divide by a fraction, you flip the guy and multiply. So really what this question is asking is tangent squared, and not tangent squared, tangent times cosine tangent secant not secant, sine. Trust the writing, not my words. I am very terrible at English. Anyway, point of doing this is if you rewrite tangent back in terms of sines and cosines, you'll get sine t for cosine t. As you can see, cosine cancels out, and you'll just get sine squared. The same thing applies to this cotangent, but I'm not going to rewrite it. I'll leave it as either A, our exercise for the viewer to do, or B, you could just take it as me being lazy. Which both of which I think are pretty good interpretations. Anyway, you'll get sine squared of t, atrocious handwriting, my apologies, plus cosine squared t. If you remember from the first problem, you'll be like, that's just 1. What are you doing? And you're right, it is just 1. There's one other proof we can do. Because remember, what we're trying to prove is that it equals sine of t over cosecant t. The thing about cosecant t is that cosecant t is just 1 over sine t. Sine over sine is just 1. So you can prove it that way. Give me a little time to rewrite that. Alright, I'll write it on the side. Sine t 1 sine cancels out. 1 equals 1. This is what all of your math has come to. Now, I'll add a little disclaimer. I'm not sure if this is allowed, because if I recall correctly, you weren't supposed to modify the right side. I can't remember though. So if you weren't allowed to manipulate the right side at all, then my apologies. I just tell you some weird method and you just lost points. But if not, your understanding just expanded a little. Anyway, last problem for today's video. Sine A divided by sine A plus cosine A equals tangent A over 1 plus tangent A. Now, I'll admit, when I first looked at this problem, I spent a lot of time looking at it, did a long method, and it ended up being long. However, when I went to go a second time, I realized this problem is a lot simpler than it looks. Because all you have to do is divide every term by cosine. So, this first term, you get sine over cosine. Or sine A over cosine A. divided by this term now is also sine A over cosine A. Plus, you guessed it, cosine A over cosine A. Now this cancels out, and it's just 1. Now, if you remember, sine over cosine is tangent. So we can simply rewrite this as tangent A over tangent A plus 1. And technically speaking, I should rewrite it, but I'm not doing all that. So that concludes today's video on pre-calc. Thank you for watching, as this is our first thing. I think that's about it. I should probably do like a little moral lesson. Do not forget you can divide by terms, because I did, and I spent my time trying to multiply by sine A plus cosine A, and that was a whole mess, and it took me a whole bunch of time. Please learn from my mistakes. Anyway, have a nice day, everyone.